Before I go into the case study itself, I'm unfortunate that I can't bring the car because everybody who has presented here has either bought a bike or has bought a set-top box or bought some device with me, but I could not convince Mercedes to give me a car so that I can bring it here. However, there are shows where with Verizon we have presented this where car was also there in the show. Okay, so what I'm going to talk about is a case study of how we manage the software components in an automotive. And actually this journey started in 2005, 2006, when all the car vendors woke up and said, well, we need to do something. Everything has become wireless. Everything has become connected. Well, I can do a lot in the car from now on. And obviously, all of us drive cars. We know how they are and how they have evolved. The head unit or the infotainment unit where you look at your map, where you have your Bluetooth connected, there are a lot of software parts which is running in that unit. Can anybody here tell me how many software parts or how many software components are there in the car? Anybody wants to take a guess? It's hundreds or thousands or 10,000s? Anybody want to take a guess? Okay, so I can give you that there are 100 modules in the car which needs software or which runs softwares. Each module could have something around 200 software parts. So you can think about 100 modules. Each module can have 200 parts. You're talking about 20,000 car parts in a car. It's a pretty complex device when you look at the car. So let's just talk about how do we maintain it, how do we update softwares on it, and security has to be the key. You don't want things to be hacked in the car. You don't want any updates going to the car which is non-secure. It needs to be coming from an authenticated source, and it needs to be encrypted, and it needs to be done right. So the case study here is really about working with Verizon Telematics and Mercedes. So challenge really was, or is, that drivers and consumers are consuming a lot of information in the car. Now you go into the car, you expect your car to give you a lot of information. Even if you go and rent a car somewhere, you will get the car which has the infotainment unit. You can take your phone, plug it in the Bluetooth, and you can make it to work. The challenge is there are a lot of subsystems in the car which is making it happen for you. And all these systems need an update. Imagine when you move from your iPhone 5 to iPhone 6, or you move from your 6 to 7 or to 8, and you bring your phone to the car. You want that phone to be connected to the car seamlessly. And why? Why it will happen? Because the car would have already updated the driver, which you have on your phone, so that it works seamlessly. So the challenge really is, how do you make these subsystems works all the time when there is a software component built into these? Second challenge, and this is for the car vendors, and actually that applies for all the vendors over here. When you have a device which is remote, especially in the cars, if I know what's wrong with your car, a priority to you bringing the car in the workshop, car companies can ship components, has supply chain impact on how they stock their parts in their warehouses and in their dealership, so that when you bring in the car, they already know what's wrong with your car and the parts is waiting for you. It's not that, oh, we don't have that part, you need to wait for 2 weeks and you need to wait 1 day, we'll give you your car and the other things. So there's an implication on the supply chain of how the car parts are supplied. So that was the challenge, is to create new business model and to make sure the car subcomponents are up to date all the time. So what happened? Mercedes and Verizon Telematics and ourselves looked at a lot of solutions, a lot of alternatives. Of course, security was a concern. Of course, you have to deliver the software and software components and parts has to be a requirement. So Mformation has been delivering software over the air for past 14 years. Today we manage close to 500 million devices worldwide. All AT&T devices, phones, get their software updated through our platform. We've been doing software update since I started the company back in '99. So we looked at the alternatives, came up with a solution which is based on an open industry standard, which is called OMA, Open Mobile Alliance, which dictates the protocol over the air, which dictates the security over the air. Today you cannot hack, or it will be very difficult to hack for you if you want to hack an iPhone or any software update or a firmware update done on an Android device from an authenticated server. So security was the key. So we created the platform which can take the software packages from different places, different vendors, create a module package and ship it over the air and gets installed into the car. The product, which we call as Impact Platform, on one hand gets integrated into the IT infrastructure where the software parts, software components come into the product. On the other hand, it gets integrated with the vehicle's telematics system over the air so that we can deliver this software parts and we can deliver these software components over the air. Again, it needs to be secure. That is one of the key things. And I walked around this conference. There is a lot of devices out there, starting from set-top boxes, bigger boxes, lights, and everybody is doing something to manage their devices. Either they're doing software update, firmware update to make sure that they are up to speed. But just ask one question to yourself. Is that secure? Is that firmware software package signed by the chipset onto the device? If it is not secure. Anybody can hack into it. If you have a CCTV camera and your updates are not happening a secure way, somebody can put a malware in it, and while somebody is watching the CCTV feed, somebody else around the globe could also be watching that CCTV feed. So over-the-air security, managing the software components, major requirements. And that was a solution which Mformation worked with Verizon Telematics as well as Mercedes. As a result, we have drivers and passengers happy with the service. Some of you who owns Mercedes, new ones, you must have heard of Embrace. Embrace is a service like OnStar, which provides over-the-air lock, over-the-air wiping, or the content, over-the-air lock, unlock the cars. And as a part of that service, Embrace also provides over-the-air software deployment, over-the-air diagnostics, over-the-air configuration, which is powered by Mformation's platform. As a result, not only the customers are happy with the service, but even the OEMs and the car manufacturers have a diagnostic capability before the car even comes into the garage, which controls how they can ship their car parts or their supply chain so that they have a better handle on the economics of that. And at the same time, the total cost of ownership providing service to your customers increases. So that's really the high-level case study from the what was the challenge, what's the solution, and what was the result. Now, how was it done? A deep dive into it. So what you have over here is the car. I think everybody knows the car, so I'll just go one step at a time. The car has an infotainment unit. An infotainment unit today have 3 wireless connections coming into it. One is built-in LTE module. Number 2, there is a SIM slot in your car. You can put in your own SIM card. Number 3, your own phone. Your phone can be connected to the Bluetooth, and you get your songs, and you get your contacts, and you get your everything in the car through that interface. So you have 3 interfaces coming into the head unit. And that head unit is connected to other components and other modules in the car with something called as CAN bus. CAN stands for Car Area Network. That's the CAN bus of how the modules within the car talks to each other. So it's like a LAN within the car, which you're talking about. What do we do? Or what Mformation impact platform do? First of all, it takes care of multi-points within the car. It provides secure software over the air. Again, the word is secure. Each software is coming from an authenticated source, and each software is signed by the keys which are stored in the chipset in the ECU. Security is the major requirement for this operation. Diagnostics. We can send scripts. If you have bought your car to a dealership, what do? They bring the machine back, they have a ODB connector, they plug it in your car, and that it runs the diagnostics through your car, and it will tell you what's wrong, what's right, because it's the computer who's reading everything. Imagine doing that over the air. So what do? We send the scripts over the air, again, securely. We execute those scripts over the air. We send a command to the ECU, execute these scripts, and these scripts will collect tons of data from various different modules, pretty much the same as what you bring the car into the dealership. And that data which gets collected, that gets uploaded, and that gets analyzed and looked at. So we are not the analytic platform like Vitria and the other guys over here. We are a management platform which provides over-the-air secure firmware updates, software updates, scripts updates, and it also provides functions like reset, reboot, and the other management plane functions. The other thing which we do is to make sure that the software parts which we delivered, the scripts we delivered, we get the status back from them. They were deployed fine, they were okay. If they were not okay, they have to roll back. Once again, users should not be impacted by this if anything is happening behind the scene. So we know if a software update has been successful or not, and we will roll it back. If it is successful, we know that it was successful. Same thing goes for the scripts which we get to the car. We need to know whether they executed fine. If they executed fine, and if they are not executed fine, we can repeat those operations there as well. What is there on the platform? Of course, it's a scalable platform. As I mentioned, we manage close to 500 million devices worldwide. Our largest deployment is 120 million devices on a single platform. We can push software updates to the size of gigs in seconds. So if there is a huge deployment where you have millions and millions of devices which needs to be updated, we are the people you should talk to. And now we are making that service available for all different type of endpoints, not just cars, meters, and the other things. The other thing which platform has is an automation capability. When a car connects, car tells you its status. When car tells you a status and say this software needs to be updated, that software might have a dependency on 5 other software needs to be updated. So what the rules engine will do, rules engine will say, okay, the car needs an update for the Bluetooth driver on the head unit for a phone. But in order to do that, I need to apply the patch for this. I need to update this software component. System allows you to do that. System will make sure that the car wanted one software part, but we could detect that it has dependencies on others. So that's the rule-based engine which is available on the platform. We manage the software car part inventory. In the automotive industry, you will find software parts or the firmware updates pretty much recognized as software parts, pretty much like your steering wheel, your vehicle tires, or your nuts and bolts. So there are software parts, have a software part number, and it's considered as pretty much in the same supply chain organization as other parts are. Of course, we have a UI and APIs available. We get plugged into a lot of different operational support systems, and then we have a UI available as well where we can show the cars, and the demo is available on the booth here on number 121 on this aisle. Unfortunately, we don't have the car here, but we can obviously show you the UI and how it looks like, how the car parts looks like, and how software components could be pushed to the car. Now, just jumping very quickly in terms of the case study, of course, this was a case study, but the platform which has been built for managing all devices. As I said, we've been managing cell phones, tablets, and dongles for a very long time, and now we have started to go into machine-to-machine. It includes complex cars. We also have done trials with GE meters and set-top boxes. So the idea is there are 50 billion devices going to be there, which everybody talks about here. Every device needs a software update. Everybody needs a firmware update. And it has to be secure. If security is the main concern, you need to look at the OMA standards, which allows you the security, proven security, hardened security, has been used for 6-7 years, and OMA is also one of the associated partner under of this organization. So jumping onto the platform itself, what is Mformation's impact platform is? So as you can see here, this is based on an open standard called OMA, and if you have an OMA capable device, whether it's a car or a set-top box or a cell phone, you can run out of the box, you can connect it into our platform, and we will do manageability functions on it. If you look at however, all the devices are not OMA compliant. That's what we used to do for past 10 years, and the last 3 years we realized that there are going to be so many devices out there. Nowadays, if I pick up my Fitbit, or I pick up a car, a toy car, or I pick up a GE meter or a gas meter, everybody has a client built into those devices. And those devices have capabilities of updating software, updating firmware, reset, reboot, manageable control, or the manageability control plane is available on those devices. So we realized to use that capability and provide a gateway concept, which I think a lot of people have talked about. The gateway concept allows you to plug in the devices into our impact gateway, and then the gateway manager on the top will provide an API to the application developers. So in this all simplicity, we provide an API on the top to the application developer who can say, device 65 update software, device 85 update software. 65 could be a car, 85 could be a meter. We handle all the complexity underneath that. The gateway also have capability of adopting to any protocols which are available, and we have done integration with quite a few. As somebody was mentioning here, you need to write the adapters for between the SDKs into the platform, but once you write it, and we have built our own adapters for Zigbee, Z-Wave, and the other things, but more drivers could be written. Lastly, closing out, who is Mformation? I think we talked about the case study, we talked about the platform, we talked about the problem of updating software, firmware securely onto 50 billion endpoint. Mformation has a proven history of doing that. We have about 50 mobile operators. We work with AT&T, Verizon, Sprint, T-Mobile here in US, and we work across the OEMs across the globe to provide the software update, firmware update, manageability platform. We have we are launching it in the cloud now, so even if you have 10,000 devices, 5,000 devices, 200 devices, 1 million devices, you are welcome to come to the platform, and we will provide you that as a service. So with that, I'll just pause here, and Carl, I think I saw your hand, and opening for the questions.
First of all, round of applause. Crowd goes quiet. Okay, are there questions? Okay, I just want a Mercedes raffled off. I'm assuming it was CES where you actually had the car available to you to do.
There were a lot of cars there, Carl.
Yes, I noticed that. Just out of curiosity, there are some people who are concerned that by all this connectivity, we also have the opportunity for hacking. So do you see this as being an entirely closed network strategy, or how do you manage when, let's say, AT&T and BMW want to, quote, manage the car or manage the data?
Yeah, so I think it's a good question, and security, I was mentioning, is that, you know, in order for a device to be completely secure, the security has to be on the metal. It has to be at the chipset level. It has to be at the firmware level. You can build security on top at the application layer. You can provide lock and wipe. You can provide antivirus and all the other stuff in the application layer. But just look at Samsung and Apple, for example. Apple does a firmware update, secure firmware update, and that is the reason why you have a secure application environment available on the top. You take Samsung device, you buy a TV, what does it do? First thing it will do is it will do a software update, firmware update. And that firmware which is coming into your TV or to your DVD player, it is secure. It is secure to the point where if you hack it, that device becomes unusable. That's what you need to be secure, is to have your firmware package which sits below your operating system, which sits on your chipset. That firmware layer needs to be the most secure layer, which provides you the security on top. Unless you secure that layer, everything is up for grabs. So to answer your question, Carl, you need to work with the OMA standards, which has been around in the industry for about 7-8 years. This is how all the phones get updated. So if you have a Samsung or if you have an Android phone, when you get a software update tab, you pull the software down. That is coming from an authenticated source, and that package is actually signed by the chipset manufacturer who's putting that chip into that device. Unless you have that end-to-end underlying security, it'll be very difficult to see how you can protect things on the top.
Excellent. Please give Rajesh a round of applause. Thank you again.
Thank you, everyone.